film screen systems are used. If a unit does not track efficiently, the result will be erratic film densities and changes in the kilovoltage. With slight modifications, the previous test for accuracy of the density control can be used to determine if a particular radiographic unit can be utilized in the automatic exposure mode with a rare earth system. To perform the test, use the same basic equipment as on the previous test, making all exposures using 6 inches of water. Make exposures at 5 increments, beginning with the lowest kVp used for photo-timed exposures and ending with the highest. Lead numbers may be used for film identification purposes. Process the films and read the densities. Number 83. To demonstrate the results of the test, plot your findings on a graph as shown. Some automatic exposure systems will produce densities that will fluctuate for the entire range of kilovolts used. Therefore, these units should not be used with rare earth systems. Other systems will produce consistent densities within a particular range of kilovolts. For example, this unit will provide fairly consistent densities at 75 kVp and above. Therefore, kilovoltages below 75 should not be used for phototimed exposures. A similar test should be performed for each unit in the department that has automatic exposure control capability. The results of each test should be recorded and displayed for the benefit of individuals using the equipment. Number 84. Several quality assurance test instruments designed for testing general radiographic equipment are adaptable for monitoring fluoroscopic units. Those test procedures previously mentioned that can be modified to measure image intensification and spot film systems include tests for kVp and timer accuracy, reproducibility of exposure, automatic exposure control accuracy, beam alignment, and focal spot size consistency. Number 85. Besides the tests that can be adapted from general radiography, additional tests are needed to verify the accuracy of fluoroscopic units. In the next series of slides, we will be discussing tests for optical system resolution, low contrast performance, tabletop exposure rates, and automatic brightness controls. There are additional tests for minimum tube to tabletop distance and beam restriction system adequacy. These tests are not difficult to perform, but the geometrical calculations needed to interpret the results are beyond the scope of this lesson. For information on these tests, refer to the supplementary references in your student workbook. Number 86. The optical system or fluoroscopic resolution tests is performed to determine if the system has suffered a loss in image resolving power. To perform the test, you will need a fluoroscopic system resolution test tool composed of 16 to 60 mesh per inch segments and a simulated patient phantom. Set the fluoroscopy controls at the lowest kilovoltage possible and at approximately 1 mA. Place the patient phantom on top of the table and tape the resolution test device as close to the input phosphor of the image intensifier as possible. Number 87. Wearing a lead apron, view the resolution test tool using mirror optics or a TV monitor. Note the finest wire mesh visible in the center and at the periphery of the field. The test device is marked so that the resolution can be determined by the lead numbers. The higher the number, the finer the mesh. Maximum resolution will be at the center of the field. Number 88. Specifications vary depending upon the viewing method or film recording mode tested. For example, when using mirror optics, a 6-inch intensifier tube should resolve 40 plus mesh at the center of the test device and 35 plus mesh at the edge. When viewing the TV system, a 6-inch intensifier tube should resolve 30 to 35 mesh at the center and 24 to 30 at the periphery. A 9-inch intensifier tube will resolve slightly less for viewing and films. If the image intensifier tube does not meet specifications, a service engineer needs to make focusing adjustments. This resolution test device can also be used to check the photo spot and cine film. Number 89. All imaging systems should be capable of resolving small, low-contrast structures as well as high-contrast objects for diagnostic purposes. The low-contrast performance test was developed to measure the low-contrast imaging ability of mirror optics and TV fluoroscopic systems. This easy test can be performed using 2 aluminum blocks and a penetrometer, which is an aluminum plate with 2 rows of holes. The 8 holes are drilled 1/4 inch, 3/16 inch, 1/8 inch, and 1/16 inch in diameter. To perform the test, position the bottom of the image intensifier 10 inches above the tabletop and lock it in place. Then place the 2 aluminum blocks and the penetrometer on top of the table, centered to the image intensifier. While wearing a lead apron, collimate the beam to the test object and view the penetrometer at between 80 and 90 kilovolts. Number 90. Count the number of holes you are able to see, beginning with the largest. Count the holes only if you see both holes of the same size. Record the results. High-quality systems should resolve both of the 1/16 inch holes clearly. The other systems are acceptable if both of the 1/8 inch holes are resolved. Number 91. Under no circumstances should the exposure rate during fluoroscopic imaging exceed 10 Roentgens per minute. If the maximum exposure rate is set too high, patients and equipment users will be receiving unnecessarily high radiation exposure during fluoroscopic procedures. To determine maximum fluoroscopic exposure for a particular system, you will need a direct reading pocket dosimeter, 2 aluminum blocks such as those used in the previous test, a lead plate 7 inches by 7 inches by 1/16 of an inch, and a stopwatch. Elevate the 2 aluminum blocks and place the dosimeter underneath them. Place the lead plate on top of the aluminum blocks and lower the image intensifier until it is in close contact with the lead plate. Zero the dosimeter and place it under the aluminum blocks. Wearing a lead apron, expose the dosimeter at maximum kVp and MA settings in the manual mode, or in the automatic exposure mode if kVp and MA controls are not available. Number 92. The length of exposure depends upon the type of dosimeter being used. For a dosimeter with a maximum reading of 1 to 1.5 Roentgens, fluoroscope for 6 seconds and multiply the reading by 10. For a dosimeter with a 5 Roentgen maximum reading, fluoroscope for 20 seconds and multiply the results by 3. Repeat the test 3 times and average the results. BRH regulations state that the maximum fluoroscopic exposure rate shall not exceed 5 Roentgens per minute in the manual mode only and shall not exceed 10 Roentgens per minute in systems with manual and automatic exposure capabilities. Number 93. Using the same basic test geometry as in the previous test, we can determine if the automatic brightness control is compensating for variations in patient size. Remove one of the aluminum blocks and place the dosimeter in the same position as before. Wearing a lead apron, expose the dosimeter. Read and record the exposure rate for the half phantom. The exposure rate for the half phantom should be equal to or less than 1/2 the values for the full phantom. Number 94. One of the oldest and most important quality assurance areas is radiation safety and monitoring. Lead gloves, aprons, gonadal shields, and other protective shielding devices should be inspected when new, at regular intervals during use, and as a result of reported problems. These devices may be visually inspected by checking for cracks or tears. They should also be checked using fluoroscopy or overhead filming. Number 95. For a fluoroscopic check of the shielding, set the controls for fluoroscopy and place the items to be tested on the table, smoothing the items as flat as possible. Place a calibrated test object on the table for comparison. This test object should be a small piece of lead or lead equivalent material that has been measured to correspond with the desired attenuating properties for protective apparel. This comparison device can be obtained from and calibrated by a physicist. Using mirror optics or a TV monitor, view the items being checked and note whether the items appear as totally dense areas equivalent to the density of the calibrated test standard. Look for light cracks or bright areas that indicate the item is defective. Number 96. For overhead checks of protective devices, adjust technical factors for overhead filming using approximately 5 MAS at 80 kVp with a 3-phase generator. Make exposures of each item with the calibrated test object placed in one corner of the film. One 14-inch by 17-inch film can be used to test the corners of 4 aprons if the test object is placed in the middle. On the processed radiographs, compare each item with the calibrated test object to determine whether the shielding appears to meet the minimum lead equivalent requirements. To be considered safe, the item should have the same density or a lighter density than the test object. The normal thicknesses for protective apparel are 0.25, 0.5, and 1.0 millimeters of lead equivalent. All items judged damaged or defective should be repaired, if possible, or should be replaced at once. Each radiograph used for the test should be marked with the test date and stored for future reference. Number 97. All quality assurance tests should be scheduled on a regular basis. The frequency depends upon several things. If a piece of equipment is used often, it should be tested more frequently than a unit that does a low volume of work. Older machines and X-ray tubes should be tested more frequently than newer ones. Critical areas, such as special procedures, should be tested more frequently than general radiographic rooms unless they are low-volume rooms. Processors should be monitored every day or at least 3 times a week because the processor is the most variable piece of equipment in the department. The radiation protection devices, if they are handled carefully, need only be checked once a year. With the exception of the processor, most quality assurance tests can be scheduled on a 3-month, 6-month, or 1-year basis. A strict schedule should be adopted and maintained. Most tests can be performed during the slack periods of the day, causing as little disruption in the work schedule as possible. Number 98. You should now be ready for Review Exercise D in your student workbook. When you have completed the exercise, turn to the answer page at the end of the review exercise section and check your work. Then restart the tape. Stop the tape now. You should have completed Review Exercise D and checked your answers. If your score is less than 80%, you should review this material again. A score above 80% deserves congratulations. It indicates that you are mastering the material. Number 99. You have now completed the audio-visual portion of Lesson 2, selecting and performing quality assurance tests. You should now turn to the Learning Activity Series in your student workbook. When you feel you are ready, take the self-test, which is a comprehensive evaluation of all material in this lesson. After you have successfully completed the self-test, see your instructor for any further evaluation. Please rewind this tape so it will be ready for the next person to use. Thank you.